Alright, in this video we're looking at everything related to pyramids. Pyramids has a base that is a polygon, so any sort of 2D shape, and its remaining faces are triangles. So let's look at one here. This pyramid here has the base of a square. And as you can see, all the remaining faces, these ones, they're all made up of triangles. So this is a pyramid. Because it has a square base, we call it a square-based pyramid. And the volume of any pyramid we can find by timesing a third with the area of the base. So that might be different depending on what shape the base is, multiplied by the height of the pyramid. Now the height of the pyramid is the length from top to all the way to the base, and we write it often with the letter H. That's going to be the length here, the direct length from the top to all the way to the bottom. And also we have a name for the length of these. They're called slants, which is different to height, because it's not a direct way to the bottom. Now, if you remember things well, or if you notice this bit here, that is exactly the same as finding the volume of a prism. So let's say we had a prism that had a base of a square. To find the area of, the volume of this, you find the area of the base multiplied by the height, which is exactly the same as here. So you can imagine, given that it's the same, only difference is that it's only a third of it. If we carefully work a way to fit pyramids into a prism, there's actually 3 pyramids that you can fit into. That's why it's only a third of a prism, which I thought was an interesting fact. The next task I'm going to get you to do, and I'm going to get you to pause the video and do it yourself first before you look at the answers, is to draw the net of a square-based pyramid, so one just like this one, and an hexagon-based pyramid, so one with 6 sides. The net is the flat version of this, like the 2D version of what it would look like. So have a go. Pause the video and have a go at this task right now and come back to the video. Pause now. Alright, now that you're back, the way I would do this, I would draw a square and then carefully draw 4 identical triangles, and I've somehow managed to draw them to look all different, but I'm sure you've done a good job, much better than me. This one as well, I will draw a hexagon and then carefully draw 6 identical triangles, and that will be the net of these pyramids. Now, if we were to find the total surface area of a pyramid, as you can imagine, we'll need to find like all the area of all these surfaces, and they're different depending on the base. So base is what decides everything. So if we look at the square-based pyramid, you can see there's the square in the bottom, which we need to find the area of. And then we need to find the area of a triangle, of one of these triangles. But because they're all identical, once we have this, we can just multiply this by 4 and they'll give us the total surface area. For this one, because it's an hexagon, if we find the area of the hexagon and then obviously we need to add all of the triangles, and there are 6 of them because hexagon has 6 sides. That's what will happen. So to find the total surface area of any pyramid, what you want to do is find the area of the base, whatever shape it is, and you need to add area of the triangle and multiply it by however many edges the base has. So like the number of sides of the base. This is only true though if we have a regular shape as the base. For example, if we had a rectangular triangle, we'll have these 2 triangles being the same, but these 2 triangles are different, so you need to just be more careful with those. But this works if it's a regular base. If it's not, then you'll just need to find them all individually and add them up. So now that we found how to find the volume of a pyramid and the total surface area of a pyramid, I'm gonna get you to pause the video again, have a go at this task, and then come back to the video to see how you went. Pause now. Alright, now that you're back, let's do this together. We know that the first thing that you do should be to draw a diagram, like a little sketch. Doesn't have to be perfect. It's really nice to visualize things. So it's a square-based pyramid. So you do your best to draw a square-based pyramid. And then you label the sides. So we're given the base length is 25, so it's 25 here. And then triangular face height. So not the slant, not the height of the pyramid, but the triangular face height. So if you can imagine one of these triangles here, I'll just draw it here. The face height we're talking about is right here. So it's this length right here. Actually, I might get rid of all this. Getting a bit messy. Meaning it's just here, and that's 22. Just right here, 22. Now to find the volume of any pyramid, what we need to do is 1/3 times area of the base times the height. Area of the base in this case is really easy to find. It's a square, has a side length of 25, so it's going to be 25 times 25, which is 25 squared. The height, however, we don't know what it is yet. We only know the triangular face height, not the height of the pyramid. So what we need to do, we need to be able to visualize that this length here to the base, and if we draw a line to the middle of the base, and then we draw a line from the top, we can make a little triangle, and this bit here will give us the height. And we know this bit here is 22, and this, I'm gonna draw this triangle over here. So just imagine this is the same triangle, 22. And the bottom length here is also just half of this length. So half of 25 is 12.5. Then we have a right angle triangle right here hidden there. Using this, we can find the height. If it's a right angle triangle, we can use Pythag to find side length. So 22 squared is going to be equal to h squared plus 12.5 squared. And we're solving for h. So I might just bring over the 12.5 to the other side. So it becomes a minus, and we're solving for h. So h works out to be 18.10. So that's the height of the pyramid. So using the height, we can find the volume. And to find the surface area of this triangle, you'll need to obviously add up all of the sides. There are 5 sides, 4 of them are made up of this triangle that are identical. 1 is the base. So have a go at finding that, and please find me in class to check your solutions.